Good morning, good afternoon, good evening. Uh, my name is Avidvesha Daivadianta with serial number of 23610252 from PCI batch 23, and I want to present my model uh, to complete my assignment of big data and data mining. So let's just get into the model. The dataset is came from the Kaggle. Here's the link, and here's the data. There's at least 21, 22, I guess, 22 column. That's of sex, age, data, yeah, systolic, diastolic, any biometric data that being assessed in around 1,100 1,500 people. And here's the statistical data. The count, mean, derivation, mean, quantile, first quantile, second, and third, and then the max value of each column. And here it's checking the missing values. There's quite a lot missing value here. And then I check the correlation metric. There's the correlation, but since I'll be using XGBoost, which is a 3-piece, so this is not necessary. Okay, then I go to imputing the missing values, make a copy, and then here's the thing. If we take a look at the data set, there is two type of height here, height in meter and centimeter. So uh, first I impute, wait, that's a second. So here's there's a data for blood pressure and systolic diastolic separately. So I'm gonna combine this missing value in systolic and diastolic from blood pressure, because the blood pressure is uh, there's no missing value in blood pressure. So that's clear, no more missing value in systolic and diastolic. Then height, we got duplicate column of height that came in different unit, so we just combine first. Yes, and there's seven, six left that still missing value. Then we got height. Uh, here I impute with formula to find the waist height ratio. To fill this, we got use this value to find the ratio, and so on, and so the other way. Then here's the left, the missing value. Then height from BMI, we use the formula again to find the BMI from weight and height. Yes. And here's the left of the then we got cholesterol, LDL and HDL. We use the Cordical formula to find estimated LDL. Then we can input this and HDL, the cholesterol total and HDL. Then use what's left in missing value. Then the last is CVD score. In the dataset, we got the CVD risk in score and in level. So we can find the median of each category and impute them. And the other one, the the remaining missing values. Here's the remaining missing value. We use median for all of them. Use median. Here we use median. And we check again. I second check the imputed as the info, and there's no missing value. It is imputed all of them, and then we go to the encoding part. Here's the categorical column that we need to encode. The YN and FN we use binary, and the level is ordinal. Is level. Here's category level, and series level. We use ordinal. Use manual mapping for all of them. Oh, wait. So the final data is here. It's all on the number. All number, and we do this again, but it is unnecessary. Then we check the outlier. Here I print all of them, and we cut these two outlier here in the waste to height ratio and the distribution CVD risk score. And since we don't use the CVD risk score, so it is okay, but we need to this waste to height ratio. We use capping on winsorization method to fill to replace this value in this to height, the outlier, with the value in the boundaries of the third quantile. And if we check again the waste ratio, yeah, it's still there. Then we go to modeling. In the modeling, I tried the different approach. One, I used the raw encoded, and then the second one is adding some related feature, which is pulse pressure, lipid ratio, and Pascal Rate law. And then the third is I use the polynomial rejection. So we combine all of this by pairing two of them, and find the top 10 most injected value. And here's the top 10, so we add this top 10. And from this three approach, the best is on the third approach. We got the macro average of F1 score 57 and 55 under training. The training process here is make the X and Y data, splitting the data into egg per 2 ratio, and then I define the continuous binary and ordinal value in order to scaling them further in the com transformer. Because we use tree based algorithm, the scaling is not necessary, and I already tried to use row plus scaling, standard scaling, and min-max, and not doing anything for the continuous feature is the best score. And here's the pipeline. We preprocessor first, and then to handle the imbalance data, there's imbalance data, use mode to oversampling. And then here's I define the classifier, XGB classifier. Actually this 7 parameter I already use grid shots to find the best parameter here, and here's the final parameter, and we got 55 score in training and 57 on the test data. And here's the confusion metric. We can see that since there is some imbalance in the data, uh, where some of the hotel predict the most in the high and intermediate class, even though some of them are wrong. And here's uh, the the part of the most impact, the most feature that have impact on the model on predicting the class. And that's it for me. Thank you.